Welcome to another session of Everyday Mathematics. Here at Everyday Mathematics, as we always say, we do enjoy solving the harder problems, but above all, we also do appreciate and see the beauty in simpler problems. So today's problem is from the MIT 2022 Integration Bee Quarterfinals, number 4, and the problem of focus is problem number 1. And we like to title this problem under the quadratic functions. Our problem of interest is the integral from x equals to 0 to x equals to 1 of negative x plus the square root of 4 minus 3x squared over 2. This is a very interesting problem. I will be introducing 3 different ways you could solve this problem. But before I jump into the solution, I'd like to thank our subscribers. Thank you so much for your wonderful support. We really appreciate your support, and we don't take it for granted. Now, for our first-time visitors here at Everyday Mathematics, what we do is we go out there, we fish for very interesting problems, and we come back with the solutions that we think are apt for the problems. Now, for our repeating visitors who have been subscribed to our channel, we really do encourage you to subscribe to our channel. For your support would really mean a lot. So jumping into the solution of this problem, the first approach that is very common to such problems is by substituting the value of x with a trigonometrical function. And so our choice here is to substitute. We say let x equals to the square root of 4 over 3 sine theta, such that when we substitute in x, the 3 disappears, and we still have 4 as a constant here that we can all factor out, and we have 1 minus sine squared theta. And so this entire value becomes cosine squared theta. The square root now reduces that to a cosine theta. So that's the first approach. So the first thing we'll do is find dx d theta, which is square root of 4 over 3 cosine theta. And therefore dx is the square root of 4 over 3 cosine theta d theta. Now, when x equals to 0, looking at the limits, therefore 0 would be equal to the square root of 4 over 3 sine theta, and therefore theta is equal to 0. When x equals to 1, that would mean that 1 is equal to the square root of 4 over 3 sine theta, and therefore 3 over 4 equals to sine square root of 3 over 4 is equal to sine theta. And that means that theta is equal to the arc sine of square root of 3 over 2. And that would now mean that theta is equal to pi over 3. So we have accounted for our limits. And the next thing is just substituting in for x and also the limits appropriately. So our integral now becomes the integral of theta equals to 0 to theta equals to pi over 3. In place of x, we have square root of 4 over 3 sine theta, and then we substitute that appropriately. In place of dx, we have square root of 4 over 3 cosine theta d theta. And then now we can pull out this square root of 4 over 3 out as a constant, and now we are left with, inside the square root sign, we have 4 sine squared theta. So this 4 can be pulled out, and we have 2. Square root of 4 is 2, and we're left with 1 minus sine squared theta. A square root of that becomes cosine theta. And so the next thing we would do is the square root of 4 here is 2, and so we have 2 and 2 here, and then we'll divide those 2's by 2 in the denominator here, and our integral becomes as simple as shown here. The square root of 4 becomes 2, and now we can have negative 1 over square root of 3 sine theta plus cosine theta multiplied by cosine theta as our integrand. Okay, then when we multiply cosine theta across, we have sine theta cosine theta here, and we have cosine squared theta. Next thing we'll do is to express this in form of a double angle to remove any squares and to just reduce it to a point where we can now integrate easily. So sine theta cosine theta is the same as sine 2 theta over 2, and so that has been replaced appropriately. Cosine squared is the same as cosine 2 theta plus 1 over 2, and now we can replace that as shown here. And the next thing is, since we have a 2 here, this 2 here would cancel with the 2's in the denominator, and now we are left with the integral from theta equals to 0 to pi over 3 of negative 1 over 3 sine 2 theta plus cosine 2 theta plus 1. Now, our constant remains 1 over square root of 3. Going forward, we now have the constant 1 over square root of 3, and we have 1 over 2 root 3 cosine 2 theta plus a half of sine 2 theta plus theta with the limits as shown here. So the next thing is substituting the upper limit to this function minus the same function with 0, the lower limit substituted appropriately. So next thing, as we can see here, in place of 2 theta, we have 2 pi over 3. In place of 2 theta, here we have 2 pi over 3. And then here in place of theta, we have pi over 3. And then minus the same position, we have 0 plugged in. So we have 1 over root 3, and here we have 1 over 2 root 3. In place of cosine 2 pi over 3, we have negative a half. In place of sine 2 pi over 3, we have root 3 over 2. And then in place of 0 here, we have 1, and so this becomes 1 over 2 root 3. And then the rest becomes 0, it just diminish. And so the next thing we do is, so we have here negative 1 over 4 root 3 plus root 3 over 4 plus pi minus 1 over 2 root 3. So we can multiply root 3 to the numerator and denominator here. So we have 3 over 4 root 3. And so that now becomes negative 1 over 4 root 3 plus 3/4 of 1 over root 3. And so negative a quarter plus 3/4 becomes a positive a half. So we have 2 over 4 root 3, 2 over 4 root 3 plus pi over 3. And when we divide appropriately, we have a half. We have 1 over 2 root 3 here, as shown here. And essentially what we see here, we have this matching with this, and so those two things would cancel out, right? So those would cancel out, and now we are left with 1 over root 3 times pi over 3. And that is the answer. Very, very interesting answer. You could even simplify it further and just say, okay, it's pi over 3 times root 3. Okay? So the second way of approaching this problem is using the ellipse approach. So looking at this problem, we could suppose that our function y be equal to negative x plus the square root of 4 minus 3x squared over 2. And so 2y plus x equals the square root of 4 minus 3x squared, which also means that 2y plus x squared equals to 4 minus 3x squared. And so expanding the 2y plus x squared, that means that on the left-hand side, we have 4y squared plus 4xy plus x squared, which is equals to 4 minus 3x squared on the right-hand side. And so when we add 3x squared on both sides, the negative 3x squared on the right-hand side disappears. So we have 4y squared plus 4x squared plus x squared plus 3x squared, which is equals to 4 on the right-hand side. And that means that now we have 4y squared plus 4xy plus 4x squared is equals to 4. So we can divide across by 4, and we're left with y squared plus xy plus x squared, which is equals to 1. And so this is an equation of an ellipse. I'll show you why it is an equation of an ellipse. We could express this first part as y plus x over 2 squared minus x squared plus 4. And then we add this x squared. And so the left-hand side now becomes y plus x over 2 squared plus this negative x squared over 4 plus x squared becomes 3x squared over 4. And so we have now y plus x over 2 squared over 1 squared plus x squared over 2 over square root of 3 squared is equals to 1. So this is an equation of an ellipse where this is a squared and this is b squared. And so we could now show that this is something akin to sine x squared plus cosine squared x squared equals to 1. So we can take this to be sine component, trying to express it as a parametric expression. So we let x be equal to 2 over 3 cosine t. And this is because when we equate this to sine squared t, this becomes the constant here when you obtain its square root. And this part becomes cosine squared t, therefore, so y plus x over 2 So now we can express this now into this formalism where we have an expression of an ellipse where this is x, this is a squared, and this is b squared. And there's an expression such that it's akin to this being equal to sine squared t, this is cosine squared t, such that x is equals to now 2 over root 3 cosine t. And so since this is equal to sine squared t, then y plus x over 2 will be equal to sine t. And since we suppose that x be equal to 2 over root 3 cosine t, that means that y plus 2 over root 3 cosine t over 2 is equal to sine t. And therefore y is equal to sine t minus 1 over 3 cosine t. So we have the value of x, which is equals x equals 2 over root 3 cosine t, and y is equals to sine t minus 1 over root 3 cosine t. So when we plot these things out, we have x versus y. It's the same as an ellipse here, where we have when, for example, y is equals to 0, when this entire expression is 0, we have this 2 over root 3 cosine t be equal to 1. And so this is when x is equals to 0. When this is equals to 0, x equals to 0, we have 2 over root 3 cosine t equals to 0. And so 2 over root 3 cosine t equals to 0 means that t equals to pi over 4, or pi over 2. And then here we have y is equal to sine t minus 1 over root 3 cosine t equals to 0. That means that the tangent of t equals to 1 over root 3, and therefore t is equals to pi over 6. So we'll have to integrate in t, where this would be from t equals to pi over 2 to t equals to pi over 6. So we've obtained that. Now, the next thing is, since our integral in x is from x equals to 0 to 1, we'll be trying to get the integral of this area here. Since the integral of this area will be, in t, will be from t equals to pi over 2 to pi over 6, and y with a small slice of dx. So we know what x is. And so if x equals to 2 over root 3 cosine t, that means that dx dt is equals to negative 2 over 3 sine t. And then dx therefore is equals to negative 2 over root 3 sine t dt. And if y is equals to sine t minus 1 over 3 cosine t, then that means that our integral now in t is the integral when from t equals to pi over 2 to pi over 6 of sine t minus 1 over 3 cosine t times negative 2 over root 3 sine t dt. So which means that now we can pull out this constant now. We have 2 over root 3 of the integral from t equals to pi over 2 to pi over 6 of negative sine squared t, since we multiply this negative sine t across, plus negative here and the negative here. This becomes positive of 2 over root 3 sine t cosine t. And so this expressed in we're going to express everything in the double angle formula, but first of all, we've got to investigate. So we have a 2 here, and then we don't have a 2 here. So what we're going to do now is negative sine squared t is, we're going to express that into cosine 2t format, but this one here is the same as sine 2t over 2, and that 2 cancels with the 2 in the numerator. So here we have 1 over 3 sine 2t. Since cosine 2t is equals to 1 minus sine squared, 2 sine squared t, therefore negative sine squared t is the same as cosine 2t minus 1 over 2. So we can plug that in there as shown here, cosine 2t minus 1 over 2. And using this 2 here, the 2 would cancel with the 2 here, and this 2 would go here. So we're going to apply that constant appropriately. And as you can see, now this becomes cosine 2t minus 1 plus 2 over root 3 sine 2t. So integrating this is the same as 1 over 2 sine 2t minus t minus 1 over 2 times this, since this, the 1 over 2 cancels with this, so we have now negative 1 over root 3 cosine 2t. Now applying the upper limit, pi over 6, and the lower limit appropriately, we have 1 over 3 into curly brackets, another bracket, 1 over 2 sine 2 times pi over 6 minus pi over 6 minus 1 over 3 cosine 2 times pi over 6 minus, open brackets, half of sine 2 pi over 2 minus pi over, this is pi over 2. I beg your pardon here, there's a mistake here. Minus 1 over root 3 cosine 2 pi over 2. So this comes pi over 1 over root 3, and then 1 over 2 is sine 2 pi over 6 is the same as root 3 over 2, since this becomes pi over 3, minus pi over 6, minus 1 over 3, 2 times pi over 6 becomes pi over 3, cosine of pi over 3 is a half, minus 2 times pi over 2 is pi, sine of pi is 0, and then obviously this is minus pi over 2, minus 1 over 3, cosine of 2 times pi over 2, which is cosine of pi, is negative 1. So this becomes now root 3 over 4 minus pi over 6, and this becomes 1 over 2 root 3, and this becomes 0, so we have negative pi over 2 plus, this becomes plus 1 over root 3. So here, multiplying root 3 to the numerator and denominator, we have 3 over 4 root 3 minus pi over 6 minus 1 over 2 root 3, and then minus minus, it becomes pi plus pi over 2 minus 1 over root 3. So essentially, what happens here is when this gets bunched with this becomes negative 3 over 4 root 3. And since we already have 3 over 4 root 3 here, this and that cancels out. And so we are left with 1 over root 3 times pi over 3, which is the answer we were looking for. And it's the same as what we obtained previously. So this is the second way of approaching this problem. So the third way of approaching this problem is by just using a visual approach. And since we do have x, the parametric expression of x being equal to 2 over root 3 cosine t, and the parametric expression for y be equal to sine t minus 1 over root 3 cosine t. What this means is that we have an ellipse here, as we saw previously, and at the location, this location here, we found that t equals to pi over 2, and this location we found that t equals to pi over 6, right? So it's kind of hard to obtain the major and the minor axis of this ellipse. This ellipse looks like it's aligned to the 45-degree angle. So one thing is to rotate it back so that the major axis is aligned to the principal axis x and y. And so we'll just do a manual approach where we use a matrix and we rotate it by 45 degrees. And as you can see, cosine 45 is 1 over 2. Sine 45 is 1 over root 2 as well. So you multiply that out, you get that expression. And so if you simplify it further, you come to 1 over root 2 times root 3 cosine t minus sine t, and then 1 over root 2 times 1 over root 3 cosine t plus sine t for the x prime and y prime respectively. So simplifying it further, we can now pull out 2, and this becomes root 3 over 2, and this becomes half. The same would happen here if you multiply by root 3 across, so that we have 1 over root 3 out here, and then pull out the 2. So we have a half here, and we have root 3 over 2 here. And this means that for x and y prime, we have 2 over root 2. In place of root 3 over 2, we have cosine of pi over 6. In place of a half, we have sine of pi over 6. And here in place of a half, we have sine of pi over 6. And then here we have cosine pi over 6 for root 3 over 2. And the constants here are 2 over root 3 and then 2 over root 6, respectively. So this now gets simplified to root 2 cosine t over pi over 6 over 2 over root 3 sine t plus pi over 6. Since the phases here are the same, we could bring in a new t prime. So we have, for the x, we have 2 cosine t prime, root 2 cosine t prime, and then for the y, we have root 2 over root 3 sine t prime. And so for a triangle with the area of interest shown here, we have now a new triangle, a new ellipse that has the major axis and the minor axis aligned to the x-axis and the y-axis respectively. We can now extract the major axis, the length from here to here, and then the length from here to here from this parametric expression. So definitely from this point from 0 to pi over to the edge here is root 2, and from here to here it's root 2 over root 3. And we know that the area of an ellipse is pi times a times b, where a is root 2 and b is root 2 over root 3. So the area of that ellipse is pi times root 2 times root 2 over 3, which is 2 over root 3 times pi. And since when we looked at the extent of the area that we're looking for is from pi equals to, is from pi over 2 to pi over 6, the difference is essentially pi over 3. So the area of interest is that pi over 3 over 2 pi times the entire area of the ellipse. And so we get the final area here to be 1 over 3 root 3 pi. And this is the same answer that we found with the integration in the first way and the parametric integration in the second method. And then here with the visual approach, we are also getting the same answer. So the problem is really very interesting. It's simple, but it's interesting in terms of just what it means and the visual implication. I hope you were able to follow through and you enjoyed our solution. If you have any question or if you have any corrections that you would like to share with us, please feel free to leave your comments in the comment section. Thank you so much. Until next time, à tout à l'heure, à la prochaine fois, and best wishes for the new year 2024. And we hope to share with you some of our work in the new year as well. Thank you so much. Until next time, bye-bye.